Revision exercise 11, question number 30. Now look at this region is bounded by the curve, the circle, actually circular arc, and x-axis and horizontal line, y equal to negative h. So, prove that the volume generated when this region rotates about the y-axis. So, the volume is this. Prove that. Because of the symmetry, all we need to do is consider this region. This region will generate the whole thing. So, for revolving about the y-axis, we will need to look at the variable in y. So the function should be expressed in terms of y, function in y. So x should be the subject. That is, we write x as a subject. And the volume can be found by pi multiplied by the integration starting from y equals to this one, negative h, up to y equal to 0. And the function in y, take the square, dy. So simple integration, don't forget that r is a constant with respect to y. R is a constant, so just take out a constant. Substitute limit, you get the answer. Actually, you can look at the result given. Okay, part B. Now, this figure shows a hemispherical vessel with radius 6 units full of water, and the vessel is tilted steadily to pull out water. So this water remains in the vessel. And theta be the angle between the rim of the vessel and the horizontal level. A is the center. And the rate of change of theta with respect to time is pi over 20 per second. Part 1. Find the distance between the water surface and A in terms of theta. Right? Just look at figure B. That means we need to find this one, which is extremely easy because we just look at this triangle, right angle triangle. So this so-called distance equals to 6 times sine theta. Okay, part 2. Volume the water pulled out in terms of theta. That means we need to find this empty space, right? Volume of water pulled out. So how to do this? Okay, just imagine that we fix the point A, and then we rotate this vessel in a normal position, original position like this, right? So you see that when we do this movement, the water level can keep constant, right? No change. We just change the vessel back to the original position like this. So the volume of water being pulled out actually equal to the volume of this empty space, and it is actually related to part A. We have found that the volume of the empty space is the volume of the shaded region generating about the y-axis. Okay, just applying the result in part A, consider the length here is what we found in part 1, that is 6 sine theta. So correspondingly, the h you should put 6 sine theta, right? So by part 1, you just put h equal to 6 sine theta, and you get the volume. Using the result here, and the volume is putting h equal to this one and r equal to 6. That is, and the answer is this one, units cube. Okay, part 3. So the volume put out is 99 pi. What is the value of theta? Okay, just solve the equation like this, right? Rearranging the terms. Use synthetic division or else you factorize this expression, resulting in 2u minus 1 4u squared plus 2u minus 11 equals 0, where u equals to sine theta. So u, that means sine theta, equals to 1 over 2, or u equal to that guy satisfying this equation, and should be rejected because the root should be greater than 1 or less than negative 1. So you get the answer, theta equal to power over 6. Okay, the last part, the rate of change of volume of water inside the vessel at that moment. That means when theta equal to power 6, what is the rate of change of water inside the vessel? So this is the volume of water pulled out, not inside the vessel. Be careful. So the volume in the vessel should be equal to the volume of the hemisphere. That means 1 over 2 times 4 over 3 pi r to the power 3 minus the volume of the water inside the vessel. And I call it V. So we need to find dV dt at theta equal to pi over 6. Okay, so dV dt equals to this one negative. Okay, take the pi first out of the bracket first, and then here 216 cosine theta, and then minus this one, so minus 17.2, and then power root 3 sine square theta, and then chain rule, differentiate sine make cosine, right? And then don't forget we need to do we need to have d theta dt. So put theta equal to that moment, that is pi over 6. Then what we need to find out is this equals to negative pi 216 cosine theta is root 3 over 2, and then minus, so this is 216 sine square, okay, 1 over 2 square, and then root 3 over 6, and then multiply everything by d theta dt, which is given here. So multiply pi over 20. Okay, hopefully you get the correct answer. Don't forget the unit per watt second.